Hello everyone, I am Shiv Panchal from grade 10. This video is an explanation on how one fidget spinner makes the other rotate due to magnetic field or the force between two magnets. I will be using concepts of magnetism and rotation to discuss this phenomenon. We will be discussing some key concepts of magnets including the force between them. As we all know, like poles repel and unlike poles attract. Here like poles are south-south and unlike poles are north and south. Now we'll discuss the force between two magnets. If one magnet center is C1 and the other is C2 and the distance between their center is a d, if they repel or attract with a force F, then F is inversely proportional to d raised to 4. This means if d decreases by a little, F increases by a lot. Now we'll discuss some key concepts of rotation. This includes torque. The magnitude of torque is F perpendicular into R. Torque is the main component which rotates the body. If torque is applied, then the body will rotate for sure. Here the body will rotate with an angular acceleration alpha, and I is the moment of inertia, which depends on the distribution of mass. We have taken two spinners here. Let's name the pink one spinner 2 and let's name the yellow one spinner 1. Here we can see the spinner has started spinning. Due to the magnetic field of spinner 1, the spinner 2 has also started spinning. There is also one more interesting observation. We can see here if the spinner is spinning slowly, then the uh, other spinner rotates. But if now it's spinning fast, the other spinner has no effect. It's getting affected a bit, but it's not spinning. We will see the reason why after in this video. Now we'll see the explanation. Here I have made a simple diagram. The four dark dots represent the magnets. The bigger one is the spinner 1 and the smaller one is the spinner 2. I have also arranged the magnets such that they attract. Now if we rotate the spinner by a small angle theta, the positions of the magnets change. Now the force is towards the new position of the magnet. Before the force was attracted towards each other in the initial position. Now we are neglecting the force due to the other magnet that has came, which is at a distance x, and the new position of the previous magnet is at a distance d. X is larger than d, hence x raised to 4 will be very much larger than d raised to 4. Hence F due to x distance magnet can be neglected in comparison to the magnet at distance d. Now let the center of the spinner 2 be C, and at the distance r let that magnet experience the force F. Let the angle rotated is theta, and let this angle be alpha. The torque experienced on the body will be F cos alpha into R. F cos alpha is the perpendicular force. This was the magnitude. The direction is given by the right hand thumb rule. The direction of torque will act inside the plane. As we know that torque is equal to I alpha, torque is being applied on spinner 2 and hence it will rotate with an angular acceleration alpha. As we are giving power to the spinner 1, the magnet M1 will go from A to B and the process will continue, and this will result in the spinning of spinner 2. Now I will explain the phenomenon that we got in the observation. When we spin the spinner 1 too fast, the spinner 2 doesn't spin. Here's the explanation. In our experiment, we were spinning the spinner 1 at a steady, slow speed. Hence, it was giving it enough time for the magnet to get a torque, experience a torque, and get an angular acceleration. But now the magnet spin quickly. The position that the magnet will acquire will be different in the same time, and it will get away far. Hence, the force changes and the torque changes quickly. It would be as if M1 has moved from A to B quickly and M2 has moved from C to A quickly without any change. Hence, the spinner 2 doesn't experience anything new. If omega would have been less, then the spinner 2 would have experienced the force and the experiment would have worked properly.